Okay, so today we're going to be looking at question 6.55S in the Chemwiki, which states that Professor Perrin is creating a solution of chemical X by taking a 20-gram sample of chemical X at 300 K and mixing it into a 150-gram liquid sample at 380 K. The specific heat capacity of chemical X is 0.75 J over C times G. Find the final temperature of the mixture. So the first thing we need to remember with this problem is that heat is always conserved. So with that information, we can then declare that Q of the reaction plus Q of the calorimeter is equal to 0. And with that information, we set Q of the reaction is equal to negative Q of the calorimeter. So in essence, that means Q is equal to negative Q. And to find Q, we have to multiply mass times the specific heat times your delta T. And always remember that delta T is your final temperature minus your initial temperature. So once we have that information, we can set these equal to each other. And there we have M times CSP times delta T is equal to negative M times CSP times delta T. And from the problem, we can easily plug it in where the first mass is 20 grams times your heat capacity, which is, and then you multiply this by X minus 300 K. X is your final temperature, 300 K is your initial temperature, and you set that equal to negative 150 grams, which is your second grams, times the heat capacity 0.75, and you multiply that by X minus 380 K, where X is your final temperature and 380 K is your initial temperature. Just note that X is your final temperature, which is what we are trying to find. And then we solve for X. The way we solve for X is we multiply 20 grams times 0.75, which we get 15 joules over C. Multiply that by X minus 300 K, and on the other side you have negative 112.5 joules per Celsius, which you multiply by X minus 380 K. With some simple math, we get 15X minus 4,500 is equal to negative 112.5x minus 42750. With that, we distribute the negative on the right side, and we get that. And then we have to multiply. We have to add 4,500 from the left side to the right side, and we add 112.5x from the right side to the left side. And we get 127.5x is equal to 47,250. And we just do some simple math and solve for x, and we have x is equal to 370.6, which we get our final temperature, which is 370.6 Kelvin.